should increase its use of nuclear energy for commercial energy production. The affirmative defines nuclear energy from the Oxford Dictionary as the energy released during nuclear fission or fusion, especially when used to generate electricity, and defines commercial as concerned with or engaged in commerce. Nuclear power is the most efficient way to generate electricity for any kind of alternative energy that exists. Compared to traditional methods such as coal, oil, and natural gas, nuclear is a cleaner source of energy. Compared to renewable energy sources such as wind or solar, it is the most cost-efficient and productive source of electricity as it can be active most of the year. According to the U.S. Department of Energy, nuclear power plants operate at full capacity more than 92% of the time in 2017. Nearly twice as reliable as coal, 54%, natural gas, 55%, 2 to 3 times more reliable than wind, 37%, and solar, 27%. Since nuclear power plants can run the capacity of 92%, the estimates that they can run for 336 out of 365 days a year. By increasing commercial nuclear energy, we'll be able to generate more energy than other energy plants, since nuclear plants can run at a 92% capacity. In the U.S.'s largest nuclear plant located in Tampa, Arizona, the Palo Verde nuclear plant generates 27.7% of the state's energy. According to the Nuclear Energy Institution, overall the annual economic impact of the Palo Verde on the state as of 2009 is estimated to be $399.4 million. On top of the economic revenue the plant makes, $1.8 billion are the property tax revenues. Annual property tax revenues are estimated at $48 million to $52 million per year. Arizona Public Service Company is the largest taxpayer in the county. In addition to nuclear plants being able to run at higher capacity and generate a lot of revenue, increasing the commercial use of nuclear will create more jobs around the country. The Palo Verde nuclear plant, it employs over 2,000 workers every year. With the increase of commercialization of nuclear energy, would further be adding more jobs to communities where nuclear plants are located. With an increase in nuclear energy, the U.S. would not have to be so reliant on non-renewable energy sources. By cutting back or even eliminating the use of non-renewable energy, it would help to reduce carbon emissions in the U.S. according to the Nuclear Energy Institute. The use of nuclear energy in 2018 prevented the emission of 528 million metric tons of carbon dioxide. This equals the amount released in a year by 112 million passenger cars. By cutting back non-renewable sources, especially coal, the amount of carbon emissions prevented each year would increase dramatically. In addition, nuclear not only saves on carbon emissions, but also produces less radiation emissions. According to Yale University, nuclear power releases less radiation into the environment than any other major energy source. The worst offender is coal, a mineral of the Earth's crust that contains a substantial volume of the radioactive elements uranium and thorium. Burning coal gasifies its organic materials. So much coal is burned in the world, and so much fly ash produced that coal is actually the major source of radioactive releases into the environment. One of the main issues associated with nuclear power is nuclear waste. While nuclear plants make nuclear waste from broken down uranium in the nuclear field, this material is able to be recycled. According to the Molecular Diversity Preservation International Multidisciplinary Digital Publishing Institute, recycling can happen in a chemical process called reprocessing, with the aim of removing uranium and plutonium from spent fuel. Reprocessing has two purposes: to reduce the lifetime of the remaining waste, uranium and plutonium are the longest living accidents, and to use this uranium and plutonium in the nuclear cycle. The World Nuclear Association states that e-processing used fuel to recover uranium as reprocessed uranium and plutonium avoids the wastage of a valuable resource. Most of it, about 96%, is uranium, of which less than 1% is a fissile U-235 and up to 1% is uranium. Both can be recycled as fresh fuel, saving up to 30% of the natural uranium otherwise required. For nuclear waste unable to be recycled, concern has been raised about where nuclear waste can be stored. In general consensus that eventually there will be no longer be enough space to store nuclear waste. However, in a source from the WIPP, the Waste Isolation Pilot Plant is the nation's only permanent underground repository for nuclear waste. Radioactive byproducts from nuclear weapons manufacturing and nuclear power plants. WIPP was designed to handle a waste stream of various forms of nuclear sludge. This source says that even with an increase in nuclear commercial energy, the repository has enough space for nuclear waste for the next several years. With an increase in nuclear energy production, a concern with nuclear proliferation may arise that the uranium used in nuclear reactors may be used for making nuclear weapons. However, many nuclear plants can use thorium instead of uranium-235. Uranium-232, which can breed uranium-233, which can be used as fuel in a nuclear reactor. Thorium is safer than uranium since it requires a source of neutrons to become fissile and cannot be enriched into weapons-grade materials. The affirmative votes.
Threat to the continued existence of the human race. We have extremely limited time to address this problem, and the potential solutions are very expensive. We only have the time and resources to choose one energy future. Will it be nuclear or renewable energy like wind and solar? Nuclear energy is dangerous, risky, and cannot grow fast enough. Only renewables can save us from climate change. For that reason, my partner and I strongly negate the resolution that the United States should increase its use of nuclear energy for commercial energy production. 3 Mile Island, Chernobyl, Fukushima. 3 nuclear plant meltdown disasters in 40 years, with only 440 nuclear plants in operation today. Even though these accidents are rare, they do occur and the consequences can be disastrous when they do. Mark Jacobson, director of the Atmosphere and Energy Program at Stanford University, assesses the risk in June 2019. To date, 1.5% of all nuclear power plants ever built have melted down to some degree. Meltdowns have been either catastrophic or damaging. The nuclear industry has proposed new reactor designs that they suggest are safer. However, these designs are generally untested and there is no guarantee that the reactors will be designed, built, or operated correctly, or that a natural disaster or act of terrorism, such as an airplane flown into a reactor, will not cause the reactor to fail, resulting in a major disaster. In addition to we cannot underestimate the threat posed to nuclear facilities by cyber hacking. In addition to meltdown, to catastrophes, and radioactive waste materials pose their own risks. These risks may be acceptable if nuclear energy could save us from climate change. Unfortunately, that is a dangerous fantasy. The first fantasy is that we have time to wait for nuclear energy. Our deadline is 2030, as The Guardian reported in 2018. The world's leading climate scientists have warned there is only a dozen years for global warming to be kept at a maximum of 1.5 degrees Celsius, beyond which even half a degree will significantly worsen the risks of drought, floods, extreme heat, and poverty for hundreds of millions of people. That is 2030, only 10 years from now, but it is not even possible to build the nuclear power plants we need if we had 60 years, according to Michael Marriott in 2014. Major studies from MIT agree that about 1,500 to 2,000 large new atomic reactors would have to be built worldwide for nuclear power to make any meaningful dent in greenhouse emissions. Constructing 1,500 new reactors means opening a new reactor about once every 2 weeks, beginning today for the next 60 years. The world's nuclear reactor manufacturers currently are capable of building about half that amount. Each nuclear plant takes 6 to 10 years to build for construction alone. Add in site identification, safety, and permitting time, and the total of time to operation can be 20 years, according to the Nuclear Information and Resource Service. We do not have time to wait for nuclear. The second fantasy is that we can afford nuclear. Each new nuclear power plant costs at least $9 billion, according to a December 2015 report by the Union of Concerned Scientists. This means that a minimum of $13.5 trillion for 1,500 reactors is needed. The third fantasy is that nuclear is clean, when it is decidedly not. Even though nuclear is cleaner than fossil fuels, the mining that supplies nuclear plants with uranium must be accounted for, making the total carbon footprint of nuclear unacceptable. The Ecologist reported in February 2015, according to the Climate Change Committee, if we are to avoid the worst effects of climate change by 2030, all electricity should be generated with less than 50 grams of carbon dioxide emitted for each kilowatt hour. There have been nearly 300 papers on the carbon footprint of nuclear power. The average carbon footprint was 66 grams of CO2 per kilowatt hour, which is above the CCC limit. Fortunately, what is a fantasy for nuclear energy is a reality for renewable resources. In May 2016, David Roberts of Vox investigated the cost and feasibility of a 100% renewable energy commercial power grid. He reported the following on the renewables roadmap produced by Stanford University scholars Jacobson and DeLucci. The roadmap show how 80 to 85% of existing energy could be replaced by wind, water, and solar by 2030, and with 100% by 2050. The result is a substantial savings relative to the status quo baseline in terms of energy costs, health costs, and climate costs alike. The resulting land footprint is manageable, grid reliability is maintained, and more jobs can be created in renewables than destroyed in fossil. As I said, we only have time and resources to choose one energy future. Every dollar and every minute spent promoting nuclear energy is a dollar and a minute we don't have for renewable energy. The only energy that is safe enough, clean enough, and that can be ready in time to avert the worst effects of climate change that are increasingly threatening every life on this planet. Michael Marriott summarized it best. Our choice is stark. We can choose nuclear power or we can address global warming. We can't do both.
You have the first question, right?
Yeah. Okay. For my first question, you had mentioned that with the risk of nuclear energy is that we have a terrorist type attack with the example you've given, an airplane flying into a reactor. Did you ever get a source for that?
We have not, we didn't, oh, yes, our source for the airplane flying into a reactor, it's just a theoretical terrorist attack. It's just giving an example, but our source is from it's director of the Atmosphere and Energy Program at Stanford University, and it was from Leonardo DiCaprio Foundation in 2019.
Okay, But did it say anything about any type of these attacks happening before?
It did not say that any of these attacks have happened before. We would also like to add that the point wasn't that it hasn't happened before, but it is that it could happen, and in increasing nuclear reactors, the number, that it would be more likely, and they would become more likely as targets.
Okay, my point of bringing it up was that it sounded more like speculation, that it's not something that's already happened, so we can't say that it would happen in the future, because there's no way of telling based on a previous occurrence that it would happen again. Do you have a question?
Yes, we'd like to ask why we aren't currently using thorium in our reactors, and if so, where?
So our sources stated that there isn't currently any nuclear reactors that can use thorium, but they have proven that thorium is a viable source that could work in reactor use. There's no tested designs of it yet.
Okay, so all just speculation.
Okay. In your constructive, you had mentioned that only 1.5% of all nuclear power plants have some kind of occurrence of a meltdown or malfunction. Wouldn't you say that 1.5% is kind of extraneous, and that there's no way of saying that 1.5% is a big enough margin for us to be concerned about building more nuclear power plants?
I would be concerned if we were building 1,500 power plants, because at that point, 1.5% would be, what, 15, 150, 100?
I don't think so.
I think the math is 100.
Okay, that's not.
Alright, yeah.
22.
Yeah, how much time do you get again for? The negative believes that nuclear is not the solution. They bring up alternative energy sources such as wind, solar, and water as ways to support our energy needs. But the real question is, how long does it take for a wind farm to pay for itself? How long does it take for solar to become efficient and actually meet our energy demands? The carbon footprint for solar, like uranium, requires mining of rare minerals so it also has large carbon footprints. And also, for what they say about nuclear plants failing, 1.1% of nuclear plants failing, a lot of those were due to error. For example, they bring up Chernobyl, but how that was already deemed to be an inefficient design that was well known everywhere outside. It was also due to overworked workers who had just not done their job properly and led to the meltdown in Chernobyl. And also, what happened to Chernobyl? That's an outlier. And also Fukushima, it's a very dangerous region to have these plants, and it's another thing that can happen. France, for example, derives 70% of its energy from nuclear power, and is also able to is also one of the greatest exporters of energy in its region, showing that it is feasible to depend on nuclear power. The U.S. investing in more nuclear power plants is what should be done, because all the negative brings up is how these other energy sources that will take long to build, they are not easy to get energy. They're not always active. If the wind stops blowing, there is no wind farm. If the day is cloudy, there will be no solar. Nuclear will always be there, no matter what. As we said, it's active 92% of the time out of the year, compared to the lower percentages for solar and wind. They are renewable, but they are not reliable, which is what we need in this time. They also just bring up, I don't know where they got the statistic for how long it takes to build. I don't know how they say it can take 20 years. From our sources that we have, it says it takes 60 years for a nuclear plant can be functional for. Nuclear is the most efficient way to keep America's energy going, as it is also it's not as harmful to the environment comparatively, since it does not produce any radiation like coal does, and it is not also site specific as as wind and solar, and also geothermal, since those are site-specific. Nuclear plants can be built anywhere to meet the demands, unlike many forms of renewable energy, which are also costly to build up infrastructure. Another point they refused to bring up was that how the jobs created by nuclear plants. They say that solar and wind can create jobs, but they refused to bring up how many jobs can be created by the building of nuclear plants that can be all throughout the country. And they say that thorium is not viable since that's just speculation. But these things are tested in theory. They just need to be built at the moment. And putting more effort for the US to build these plants is exactly what needs to be done to get that testing underway. Because right now nuclear is underfunded and it needs to be dealt with. And the affirmative rest.
We have 30 seconds of planning time.
Yes.
And also, I should say, they are giving 3 minutes of prep time, actually, not.
Oh,
3 minutes? Okay,
Oh.
so we'll take a minute then.
Yeah, we're showing you that.
Thank you.
We have to stop.
Stop there. The real issue here is not whether to use nuclear or not, but is the survival of our climate on our Earth. The UN states that we only have 12 years to fix our carbon emission before irreparable damage is done. And on average, it takes 20 years to build a nuclear reactor. We simply cannot build a nuclear reactor and use nuclear power as an efficient replacement for fossil fuels because it does not fit within the time frame to save the planet. However, renewable sources can do so because on average, it only takes 6 months to build a 15 megawatt wind farm and only 2 months to build a 10 megawatt wind farm. And that's just wind power alone. When you factor in all of the other renewable sources, it is very obvious to see that by building renewables instead of nuclear power, we are able to save the climate and decrease our dependence on fossil fuels and decrease carbon emissions in the United States. The opposition claims that thorium works in theory. However, what does not work, or what works in theory and in real life, is renewable. The United States currently uses renewables, and renewables in the past have provided a constant allotment of power, and thorium has not produced any power because it's done in theory, like I said. Reprocessing has also not been done, as stated by the reprocessing is also in theory and is not applicable to our current nuclear state. Nuclear also has a higher carbon footprint than that of renewables, 6 times the carbon footprint of renewables. Therefore, it's obvious to see that we must use renewables as a source for energy rather than carbon, or to reduce carbon emission rather than nuclear. Nuclear is not the most cost efficient. It's not the most cost efficient because, given our 10-year time frame, or 12-year time frame, renewables are the obvious solution to our carbon emission, and nuclear is simply just not going to do it. The opposition claims that we said that nuclear plants are alive for 20 years. However, we didn't say anything like that. That was a total fallacy was made up. We both agree that the climate is the main factor here. However, nuclear cannot save the climate, and nuclear can save the climate. Therefore, it's obvious to see that renewables are the solution, and we should not increase nuclear power, and should instead spend our money on renewable energy because it is the obvious solution here. The negative rests.
Yeah, we apologize.
So I'm asking questions, right? Okay. Are you aware of you provided thorium as a solution to cleaner and less nuclear waste? Are you aware of the disadvantage of thorium?
Well, yeah. What is the relevance of disadvantage for it? Yes.
Sorry.
No. What is disadvantage for it?
What are the disadvantages? Thorium has a higher melting point, making it more dangerous, a much higher melting point than uranium oxide, making it a more dangerous method, and it has huge startup costs as compared to uranium, making it an unrealistic.
What do you mean by huge startup cost?
Huge startup cost?
Yes. What are the costs that make thorium more difficult than uranium? It's more prevalent material, or more prevalent mineral than uranium, so it's easier to get.
It's prevalent in the Earth's crust, but that's not that's thorium. You need to melt thorium into its fizzles for it to be used in a reactor, and that it's
Well,
not.
thorium itself, it's not just it's an acceptor. You can breed uranium 233, which can be turned into weapons basically. So that's why it's more effective, and it's more controllable. So if it keeps going, we'll just keep going. So that's why it's safer and more efficient to use, because it needs something to donate its neutrons.
All right.
I have a question for you. For a 20 gigawatt wind farm, what do you mean by a 20 gigawatt wind farm? Like, is that how much it produces?
Megawatt.
Megawatt.
That's how much power it produces.
What's the metric? How often? How much does it produce? Or what's the time period for that?
The source only gives the title as the
So as far as we know, that's 20 megawatts, right? That's 20 megawatts in what, 10 years?
No, 50.
50.
Annually. I believe that
Yeah, it should
when you
be
refer to
annual.
a wind farm, it's megawatts per year.
And how often is the wind farm up? How long is it working?
The capacity factor doesn't matter if we only have 12 years to limit climate change and it takes 20 years to build a nuclear reactor.
Yeah, and if the wind's only blowing half the time, then we're not going to do everything.
If we only have 12 years to save the climate, then if it takes 20 years to build a nuclear reactor, that power's not going to do anything.
Yeah, and so what are we going to do with the wind that we can't use?
What are we going to do with no nuclear power that we can use by the time irreparable damage is done?
You see, if you don't spend more time to work on it, then we cannot improve the time to build a reactor.
Sorry?
that we cannot improve on our methods of building reactors since
Could you
they're
repeat that?
not.
Sorry, I didn't catch.
Sorry, I'm talking too fast.
It's all good.
That you cannot, if you build a reactor, if we build more, we should get better at building them to build them more efficiently since we have a time crunch.
Do you have a source for that?
I'm saying this is typical with innovation.
Do you have a source for that?
It's for what?
That's typical for innovation. That's an outrageous claim.
I don't have a source for that.
Okay.
But
So, despite there being power in the future, we need power now to reduce the dependency on fossil fuels. With 90% of the United States carbon emission coming from anthropogenic CO2 emission from power fueling, that's now. And in the future, by the time all that carbon emission is happening, or has affected and has done irreparable damage, nuclear can't save it in time, and renewables can, because it takes less time to build, and because even if it's producing less energy than nuclear may, energy now is better than energy later, so we can reduce our dependence on fossil fuels.
how much space does it take to build a wind farm? What's the land area required?
It's irrelevant because the power to be obtained by the wind farm.
So you're saying that how much land we burn to make this to use this energy is not important?
Sorry?
Because if it's not space efficient, that does not make it energy efficient. I'm asking for the space.
So you're talking about land waste and renewables. Since wind is not the only renewable energy source we use. We can use solar, can be used, hydropower can be used, and solar can go on your roof. It doesn't use any additional land. And land waste and other renewables is not going to make a problem because if renewables do use more land than nuclear plants, those solar and wind farms will be situated in sparsely populated areas like a desert in the southwest.
That's not good.
My 3 minutes.
Yes.
Okay. All right. So the negative had mentioned first in our first crossfire about, or in the first constructive, about 1.5% of nuclear plants being able to, that are experience meltdowns or go through accidents. And then they had mentioned in the crossfire that with an increasing amount of power plants, they would go up. The math was a bit spotty, but the mentions of it going up, that the rate of accident would go up is purely speculative, since there's no way to prove that the statistic would go up or down at all. They mentioned theoretical on nuclear terrorist attacks with no solid source proving that was true. And with the 1.5%, the most well-known nuclear meltdowns that they bring up are Chernobyl, which was due to a build error, and Fukushima, which was an extremely rare occurrence, as that happened due to a natural disaster in Japan, not necessarily due to any fault of the nuclear power plant. They had mentioned that that wind and solar are one of our only alternatives to nuclear power, but I'd like to bring up that we had mentioned in our first constructive that nuclear power plants run at an extremely higher capacity than wind and solar. They run at a time 92% capacities, where wind and solar only run at 37 and 27% capacity respectively. So while they're mentioning that these are expensive, and they will, however, pay themselves back faster. As I mentioned, they run 336 out of 365 days at 92% capacity, therefore producing more energy than the other sources can. They also mentioned that we don't have enough time before nuclear or climate change occurs with irreversible damage. But they had, I don't think they had given a direct source for that. I'm sorry, I didn't catch it. And again, mentioning back that they're expensive, like I mentioned in my first constructive, the Palo Verde plant in Arizona, not only does it make revenue of 1.8 billion just on its own, it also makes an additional upwards of $50 million in revenue every single year on property sales tax. So we can prove that by having more nuclear plants for commercial energy production, they would be producing more money to put back into themselves. It talks about carbon footprint, but as we mentioned in our first constructive, the amount of nuclear plants being built have helped save on metric tons of carbon emissions themselves. And not to mention, their whole argument was talking about climate change, but the resolution was talking about commercial energy production. So here
3 minutes. All right. Okay.
Fancy.
Yeah, say. So we would like to start off by pointing out that the affirmative didn't address in our negative constructive that we mentioned the threat posed to nuclear facilities by cyber hacking. And we have sources that say that that cyber hacking is actually very dangerous and has been shown to legitimately endanger our nuclear reactors. First of all, an attack that allows hackers to manipulate the systems that control a nuclear reactor, while very difficult, could have serious consequences, including potential nuclear reactor core damage and off-site release of radiation. This is a source from this is the NTI. Additionally, they added in very recently a new piece of dangerous malware, Trisis, which specifically targets the industrial controllers used for safety critical applications, including nuclear plants, has been found in the Middle East, meaning that we could possibly get, especially with more nuclear reactors that would be needed in order to, like the resolution says, increase nuclear energy capacity, it would make them bigger targets for not only regular terrorist attacks, but also cyber hacking. We also would like to point out once again that it does not matter that that nuclear is highly has a high capacity factor when we're talking about a time limit here. The UN gave us a 12-year time limit, as The Guardian quoted, and additionally, when we're talking about our time limit, we have a source from MIT and international commissions that say that it'll take more than, most reactors take 6 to 10 years, and by the end, it'll take more than 20 years. So time limit wise, we don't have the time for nuclear, because renewables being much easier and quicker to produce, we have to use renewables, essentially. Their theoretical thorium also is just straight speculation, and if we're talking about real versus fake, renewables is a real thing that we can quantitatively improve on to actually make, help the environment. We all realize that the environment is a massive issue and that many people will die from this. That's why we believe that we need to go straight renewable or not increase nuclear, because any amount of money spent on nuclear is going to be not used on renewables. And since money doesn't grow on trees, it has to come from somewhere. We would, all right, thank you.
Would you have cyber terrorism in your constructive?
In our constructive, we,
The first contention.
it was in the first contention, yes.
Can you put statement to me, please? Where you said cyber terrorism?
Additionally, we cannot underestimate the threat posed to nuclear facilities by cyber hacking.
And which examples do you have of these? How many examples have there been?
How many examples has there been?
Of the cyber.
Um,
There was, I know of the U.S. attack that was used against Iran because they were using the nuclear program as a guise to build their nuclear weapons, but that was designed to be used once with Sputnik, etc.
So there is the Stuxnet attack on Iran's uranium enrichment facility, generally attributed to the U.S. and Israel.
But this attack allows for future attacks to happen.
But we are just showing that there is the possibility of future attacks and that there is this malware, Trisis, that can and will attack nuclear facilities.
And how are renewables safe from this then?
Nuclear.
If you shut down a wind farm, the wind's just gonna stop.
Yes, now we won't meet your energy goals, we cannot save the environment, can we not? For sure.
Well, additionally, how you are saying how much more energy one singular nuclear facility can produce. But if that one singular nuclear facility has a meltdown, not only is everyone going to freak out about that meltdown, but in comparison, your multiple different 50 megawatt wind farms, one of them being shut down, is nothing in comparison to one nuclear.
Cyber attacks can target more than one facility at once.
The effect of someone shutting down a nuclear farm or a solar panel is nowhere near comparable to the effect of someone shutting down a high pressure nuclear reactor where it could explode and kill everyone.
Well,
Let's move on. Would you agree that nuclear can decrease carbon emission? Obviously.
it's a loaded question.
You would agree that nuclear can decrease carbon emission, right?
That's something, can you ask me a question that I can answer better, please?
Sorry. Does nuclear decrease carbon emission?
It does decrease carbon emissions that,
Okay, great. So, in order to decrease carbon emissions, do you have a time frame that it would actually have a significant decrease?
a time frame for that, decrease carbon emissions?
Like how many power plants do we need before the power created decreases dependency on fossil fuels and actually changes carbon emission?
Oh, we have a source for how much is decreased per nuclear plant, but we don't actually have an exact number on how long it will take.
So, no matter how fast you try to build power plants, this is from the
World Business Academy.
No matter how fast you try to build new power plants, there simply aren't enough engineers and technicians with the required expertise to build the number of power plants we need. Additionally, major studies from MIT agree that about 1,500 to 2,000 new atomic reactors would have to be built worldwide, not just in the United States, worldwide.
We're talking about the United States, not worldwide.
Yeah, but this is
So you're saying
even better. So the power created in the United States can't decrease carbon emission, or can decrease carbon emission. But
So you're
it can't
wait, you say it can't
significant.
decrease carbon emissions? Is that
No,
your whole
of course-
idea with renewables?
No, of course it can.
So you just said it wouldn't. You're
No, sorry, that's a
You're saying
fallacy.
only if nuclear power plants can reduce it, but renewables can?
I don't understand what you're saying, but I'm going to continue.
Fair enough.
Major studies agree that. Sorry. All right.
Yeah.
Already. The resolution states that the United States should be having more nuclear power plants for what's called, you know the word, use, commercial use. What they're going off is not for commercial use. They're trying to protect the environment, which is not what the resolution is here to state. They're saying how nuclear power plants in the United States will not decrease carbon emissions because apparently something needs to be done worldwide, but their argument is entirely based on the fact that renewable energies will be able to decrease carbon emissions, which is a logical fallacy saying how something needs to be done worldwide, which means it also needs to be done worldwide for them as well. And they also said themselves that it produces less power, but they want to make their time go quickly. Well, for nuclear power, from the affirmative says it will produce this power and it will produce this much. It will always be active, and you can always rely on it to be there. While we've already said how it's a bit spotty in our constructed area, said how a lot of renewable resources are a bit spotty and are also very location dependent. And another thing, how they can actually disturb wildlife, like how wind farms are capable of killing many birds and bats per year, which we remember earlier. But and also for wind or for solar, and also bring up the what it costs to make solar panels. Not everyone can afford solar panels. And they also say how if one nuclear plant goes down, well, and the area that's powering it also goes down, but it also adopting the fallacy of if the power that's being provided by a wind farm, that circuit of wind farms goes down, well then they're all down. And it's basically the same thing either way. So their cyber attack point is really null and void because no matter what happens, cyber attack on power plants is a cyber attack on power plants. No matter what the power is, that power will be gone and they cannot do anything about it. Another thing that they also bring up is they also say how thorium is not viable because it is only in theory. Rome wasn't built in a day. We can't just say, well, we don't have this now, so we can't use it ever. But thorium is something that can happen, and it's been proven to work. We know it can work. We just haven't built it yet. We're getting to that point, which is why we need to keep putting research in nuclear. We know what nuclear is capable of, and we know that all that it can do. It can provide so many jobs, and it also can be built anywhere compared to many environmental things, which are limited to space, which is why the affirmative is the correct choice and we should be voted for, since we are actually going on what the resolution is and not trying to meet some environmental goals which are unmeetable according to their own logic. The affirmative.
Cost, capacity factor, and safety all matter all don't matter when we are given a time frame by the United Nations. Within 12 years, as stated prior, we have 12 years to fix our carbon emission, the world's carbon emission, before irreparable damage is done. The resolution states increasing nuclear power for commercial energy production, but commercial energy is still energy regardless, and this energy in turn either has an increase in carbon emission or decrease in carbon emission. And while nuclear does have a more effective effect on carbon emission, it's not going to be done in the time frame that the UN has given us before irreparable damage is done, meaning that renewable sources are obviously the way to go, or the way to go, and when concerning carbon emission and the time frame the United Nations has given us. Thorium may be safer theoretically. The opposition said, quotes, it's getting to that point where it will work in the future, but we don't have time for that point. We have 12 years, like we said before, and those 12 years offer a time frame for us to fix it now and fix our carbon emission now. It is technically and economically feasible to run the U.S. economy entirely on renewable energy and to do so by 2050. That is the conclusion of a study last year in the Journal of Energy and Environmental Science. While that timeline is at 2050, increasing renewables now rather than increasing power from nuclear later still affects carbon emissions within the time frame the United Nations has given us. The opposition claimed that nuclear is cleaner. However, nuclear emits less carbon. While it still emits less carbon than fossil fuels, it still emits 6 times the amount of renewables. And mining for uranium has an even more detrimental effect than renewables. Our choice is stark. We can either choose nuclear power or we can address global warming. We can't do both. The obvious solution is to negate the resolution to increase nuclear power for commercial energy production. Because by increasing nuclear power, we spend our money on nuclear resources instead of renewable resources, and thereby don't impact our dependence on fossil fuels now that we can do with renewables, the negative rests.